Hello everyone, I am Jaydev and I am second year BTech AIDA student. Today I am excited to present my computer organization and architecture project, an Arduino based calculator with web serial interface. This project demonstrates fundamental COA concepts including von Neumann architecture, control unit design, ALU operations, register management and real-time I/O interfacing. This project integrates both embedded system programming and modern web technology, showcasing a complete hardware-software system. Now let me explain the computer architecture mapped with this project. The control unit. In my Arduino code, the redirect key function, it acts like an instruction decoder interpreting commands from the web interface. When the web interface sends character like digit 5 or A for addition, the control unit decodes the instruction and decides what action to be taken. The ALU implement the calculate function in this place where arithmetic operations will be happen. It switches between 4 operations like addition, subtraction, multiplication and division. Notice the safety feature for division. It checks the divisor is 0 to prevent undefined behavior. This is similar to how real CPU handle exceptions. Registers. These are my global variables. They store data temporarily. Number register. This is the accumulator register storing the current number being entered. Num1 and num2 register. These are general purpose register storing first and second operands. Action register. This is the instruction register storing which operands to be performed. Plus subtraction, multiplication and division. Result register. This is my control flag indicating when the calculation should execute or not. Input and output interface. The Arduino communicate with web browser via USB serial at 9600 band rate and serial.begin function initialize in 9600 to initialize communication between Arduino and web interface in 9600 band rate. Serial.read function receives commands from the web interface and serial.println sends result back to the browser. Now we will see how it works together. When the user clicks the button on the web interface, the JavaScript sends the character via USB serial port. Then the Arduino receives it from the loop function. The control unit decodes the instruction. If it's a digit, the accumulator stores it. If it's an operator, registers are configured. When the user clicks the equal to, the ALU performs the operation. The result is sent back via to the web browser. The JavaScript update the display. The entire cycle mirrors the real CPU fetch, decode, execute cycle, just as in a simpler scale. The beauty of the design is modularity in each component as a single well-defined responsibility, just like real computer architecture. Now let me show the hardware setup. This is an Arduino Uno R3 microcontroller. It has ATmega 328P processor running at 16 MHz. My program uses 2670 bytes program memory out of 3256 bytes available. That's 8% utilization. And 203 bytes of DRAM out of 2048 bytes available. That's 9% utilization. Very efficient for such functionality. The Arduino connects to my laptop via USB cable. This provides both power and serial communication. The USB serial connection operates 9600 band rate. That's 9600 bits per second of data transfer. This is fast enough for real-time interactive use while being reliable for the serial communication. On the software side, I developed web interface using HTML5, CSS3 and JavaScript. This interface uses modern web serial API, which allows browser to Arduino communication without any additional software beyond web browser. This is more user-friendly than traditional Arduino serial monitor and demonstrate the modern web technologies. Here is the web interface I created. The design features are a matrix rain animation background. It gives a modern tech forward aesthetic look. 4x4 keypad with numbers 0 to 9 and operation buttons. A display area showing current number and expression history. Then the connection status indicator for the Arduino is connected or not for the indication purpose. Arduino connect button for establishing connection between the Arduino and web browser. The color scheme uses green and black inspired by classic terminals interface with modern glass morphism effect and smooth animation. Notice the layout. It's responsible and touch optimized, which means it works well on different screen sizes and touch devices. The interface is intuitive and matches the standard calculator layouts that users are familiar with. Now let me connect Arduino and see the action. When I click the button, the browser requests permission to the USB serial port. The browser shows the available serial devices. I will select the Arduino port, click confirm permission. Perfect. The connection is established. Now the status indicator changed to green and shows tick it's connected. The Arduino is now ready to receive commands. Now the display shows 0, the initial state when calculator boots up. Now let me demonstrate the calculations. Let me show 4 basic arithmetic operation. Addition. I'll calculate 25 plus 17. I'll click 25. Then it shows in display 25. I click plus button. What happens? The display clears. That means the expression of the above area 25 plus operation. The calculator is waiting for the second number. In the Arduino, num1 register is stored 25 and the action register stored plus. Now I enter 17. Then I click equal to. The Arduino stores 17 in num2 register. Calls the calculate function. Executes the addition operation. 25 plus 17 is equal to 42 and sends back the 42 via the USB serial port. Then the JavaScript receives it and finally it updates in the front end. Then the result is displayed in the web interface. Subtraction. Let me calculate 50 minus 18. Let me enter 50, press minus, enter 18. The Arduino computes 50 minus 18 and the result is 32. And the multiplication, calculates 6 times 7, enter 6, press multiply, enter 7. The Arduino computes 6 times 7 is 42, it's correct. And division, let me calculate 10 divide by 4, enter 100, press divide, enter 4. The Arduino computes 100 divided by 4 is 25, it's correct. And the bonus, this interface also support keyboard input. Let me demonstrate. Typing on the keyboard automatically enter the digit. I can press plus key to add, enter the amount of number, press enter to calculate. Result 1887. The calculator handles large multi-display number perfectly. The clear function. To reset everything, I press C button or keyboard. I can press C or escape. To clear from the keyboard, everything returns to the initial state. Number register becomes 0, num1 and num2 register also becomes 0 and the action register also become empty. The calculator is ready for the new calculation. Technical insight. Let me highlight the key technical aspects that demonstrate COA principle. The control unit implements a state machine. The each key press transitions between state, waiting for the input, accumulating the digits of operand pressed, accumulating second number, then the execute. This is the exactly how real CPU control unit works, processing through the state like fetch, decode, execute and write back. Registers operation. The register store state information between the operation. This is essential because serial communication is asynchronous. We can't process a full calculation until all input arrives. The register maintain the state perfectly. Error handling. Notice the division operator include check if num2 is not equal to 0. If divisor by 0 occur, it returns 0. Instead of crashing or producing a undefined behavior, real CPU has exception handling for similar scenarios. I/O synchronization. The loop continuously checks if serial.available function is greater than 0. This is pulling constantly checking for input. When data arrives, it's immediately processed. This is how real system handle real-time I/O. Memory efficiency. The entire program uses only 8% of program memory and 9% of RAM. This demonstrates efficient code design crucial for embedded system where resources are limited. Modern integrations. Finally, the Web Serial API demonstrates how classical computer architecture concepts integrate with modern web technologies. The browser acts as an I/O device communicating with the embedded system in real time. This is a bridge between low-level embedded system and high-level web application. Conclusion and summary. This Arduino calculator project successfully demonstrates core computer organization and architecture concepts. Von Neumann architecture, separation of control unit, ALU and memory. Instruction decoding. The control unit interrupts serial commands. Register management, data storage and state maintenance. ALU operations, arithmetic computations, I/O interfacing, serial communication with external system, error handling, division by 0 protection, real-time processing, interactive responses. This project is enhanced with modern web technologies, making practical and user-friendly. Thank you for watching this demonstration. For complete code and documentation, visit my GitHub repository. Questions are welcome. Give your comments. Thank you.